we thought we'd turn on the microphone. Okay. We thought we'd try something a little bit different. A couple months back, we were hoping to find a bunch of HPC sites that wanted to offer opinions or say, hey, we are actually starting to use our large-scale systems with some external cloud computing. Anybody in the US federal government space is probably aware of the Cloud First initiative that came out, I'm thinking early 2010s, 2011, sometime around then. And the information we got was that when you are doing a new, I'm not so sure if it was initially just saying augmentation or providing a new system, you should consider, if you are a federal government agency, doing it with commercial cloud in some fashion first before you decide to deploy it in your own local data center. So until very recently, it was pretty easy if you were large scale to make the argument that it just wasn't cost effective, that the services weren't there, that the data feeds weren't there, things like that. In the recent past, things have, at least from our point of view, from a storage providing facility that may be growing at about a petabyte or two a month, and retrievals maybe about half of that. We've actually started opening our eyes and looking around and saying, well, let's take a look. What could cloud storage do for us? So as I said, a couple months ago, we tried to think of some others who might be doing the same thing. Surprisingly, didn't find too many yet in the federal government space. I do know of one group that has been following or enabling this kind of thing. A couple of years back, the National Institutes of Health has enabled a cloud pilot project for the cancer genomics. They have 3 different cloud offerings with integrators and tool sets on top. 2 are in Amazon, 1 is in Google. And I believe that they've populated the genomics data sets in these cloud areas, and they have, the individual providers have the tool sets, and then a principal investigator will submit a proposal to NIH and say, hey, I'd like to use this, and if their proposal is awarded, then they get basically a preloaded credit card that says, you know, you can use this on one of these cloud providers. So that's kind of an interesting concept that seems to work well so far in that kind of space. So, but back to our more traditional large extreme scale HPC. Not so many people are trying it yet. As you saw, we have our little Head in the Clouds project for looking at counting trees and shrubs to estimate carbon mass in Africa. That's a specific project and definitely optimized to reduce the amount of data movement that was moved back and forth. So we thought we'd just start out by asking a couple of questions. First, if people don't mind a show of hands, since the camera's on us and not you guys, how many people have considered looking at cloud storage? All right, that's perhaps more than I might have thought. How many are actually using it at present, external cloud storage? Okay, good. How many think it'll be a good long time before they'd consider using external cloud storage? Yeah, okay, all right. So for those who are using cloud storage or are considering it, we're kind of turning the tables here. What kinds of things are most attractive to you in terms of the cloud capabilities, ignoring the economic aspects of it? Is it the ability to flexibly back-end your Your large-scale storage, the ability to offer these approved images or these tools that you can slap on top of it and let your researchers access the data. Is it strictly economics so that you don't need to keep doing the data center upgrades and the movement of your data from one technology to the other? Have anybody interested in offering an opinion?
For us, maybe.
Do you want to, could you maybe come here or there, please?
Yeah, thanks.
Well, all right. Well, he's going. I think the primary issue is elasticity. So you can go from very little or none to a massive amount very quickly, and then back to very little. It's certainly true that most HPC workloads are kind of long running, and so that's a classic case where the CapEx kind of works to your advantage. So I think that's part of it. But yeah, being able to scale and then in some cases take advantage of the economics. There are vendors that will let you have a petabyte in the archive in the cloud for $12,000 a year. So it starts to get interesting. So an exabyte is 12 million. That's an interesting cost point. So anyway, go ahead.
So yeah, for us at the Weather Centre and European Weather Centre, we've looked at DR for so using cloud as a DR purpose. So we have currently obviously a large archive and a smaller disaster recovery system, and we looked at, well, we're looking possibly at replacing that at some point with a cloud system, but yeah, we're also looking at tape, because tape is still, we're finding cheaper to store vast amounts of data on tape than in the cloud.
Thank you. Are there others using cloud or considering using it as a DR?
So I work at a private enterprise with HPC and analytic workloads. We don't have a lot of data that we're put in the cloud, but we do have cloud storage that we're using, probably on the order of a petabyte or 2. It was done purely for economic reasons, and as Matt had mentioned, because of the elasticity, we didn't know how much we needed and how much we would use. But it's not something we want to be in long term, so we're actually going to be bringing it back in-house.
So I guess one of the interesting things for me when you're talking about elasticity is it's a little easier to think about being able to spin up compute instances than it is being able to spin up populating petabytes of data and have that available for a bit and then not anymore. The persistence of storage is, as has been talked about in other sessions, it's a different beast.
Yeah, so we use, so I worked on a couple different projects where we do use cloud for backup and DR, traditionally just pushing into object storage. The big thing is that you have to be careful about is the size of your object that you're retrieving. So we got like a 70 petabyte backup we do with AWS. Retrieving those, kind of the way you tier all that out, you have to set it up appropriately when you start. Think of the use case and how you're going to get it back out. If you have a, terabyte object you have to pull out of Glacier, it's going to be really expensive. So little things like that. The other benefit is the application scalability from a user perspective. So if you have, a lot of users you want to give access to your data, the cloud is good for that. But research workloads we usually don't ever throw in the cloud. So we try to keep those on our own stuff.
So my experience is just with AWS, so I'm unfortunately going to pick on them a little bit. I mean, their cost model is based on the idea that you're computing in the cloud with your data. So they're happy to ingest your data for free. It's when you want to get it out that it becomes expensive. We did just an analysis on paper of storing a large amount of genomic data that we were getting in collaboration through the cancer moonshot kind of project. And the cost for egress, if the model was park your data in the cloud and then pull it into the HPC center based on the idea that we're not going to run a 10,000 node HPC cluster in the cloud, the egress charges were 3x the storage costs. So you definitely need to factor that in. I mean, there might be storage cloud solutions that are priced differently, but, you know, that was our
So,
experience.
yeah, so cheaper egress options, maybe like a Snowball, say Amazon, Oracle has mechanisms for that as well. Yeah.
I will add that moving to cloud is a tougher pill to swallow if you've been doing this for decades. So NERSC is coming up on our 45th anniversary, and we existed before cloud was even an option. So we've gotten used to having to deal with the inability to be elastic. And in fact, the way we procure storage is not on a quarterly basis like many private industries. We do multi-year procurement cycles. So we buy what we need before we need it. Maybe it's not the most cost-effective way, but we have room to grow, and we can see the end of the runway coming long before it does, as long as we're doing our planning correctly. So elasticity, you know, I don't think that it's cost-effective for us to. We don't need to pay the price for elasticity because we have been dealing with that for a long time.
I know there have been some studies that have been reported on the web recently. I think 451 Research is one of the ones that you know, looks at CEOs or CIOs every so often, and you know, so reportedly there are increasing enterprises looking at using cloud, but one of the things that, of course, is kind of bubbling up as people are starting to use cloud is, well, what kind of strategy do you have for moving out of the cloud, like the gentleman was talking about earlier? It seems like that's something that needs to be considered. Storage tends to be long-lived. Your data may live longer than depending on where you go, than your storage vendor. So that's one of the concerns people have. NASA is, the CIO in NASA has put together an offering that they're strongly encouraging, the managed cloud environment, and part of the reason they're talking about this is as most federal government-related folks are aware, there's increasing needs to report and audit what's going on. The recent continuous, detection and mitigation efforts that are becoming very, we'll say, stringent and take quite a bit of resources. The idea here with these managed cloud environments are that you can spin up what you need and the CIO can report very quickly, have they done these mitigations against, you know, the WannaCry bug or whatever else has come in. Have you, and there are ways purportedly to, you know, detect what's going on and ways to report. And so we're also strongly being encouraged to use that kind of thing. I imagine there are other agencies doing something similar. Most of us agencies are required to do the FedRAMP, FISMA requirements for the low, moderate, high in the cloud. That's one of the things that we have to look closely at. So any comments on concerns about the security infrastructure or the requirements that could be deployed or enabled in the cloud, whether to be harder or easier, or it's a big obstacle for you? Our particular facility is lucky in that we have very little in the way of export-controlled data. It's almost all science data. So we don't have much in the way of, it has, for the sake of protecting information, I'll say in terms of secrecy isn't the right word, but it's okay if anybody would happen to jump over and see this data for the most part. So
Right,
we're
but
looking-
but there are also some folks from places where, you know, they can't even be connected to the internet. So it's like
Right.
almost the extreme opposite.
Right.
Go ahead, yeah.
So I had mentioned that we were in the cloud earlier and that we're trying to get off, but part of us making the decision to go there, because it was a little internally, there were people who were for it and enough people who were against it. And it was done mostly because it was going to be easy and we couldn't project what we needed. So that was a big problem. So in order to get, we are expert controlled. So in order to get around that, you know, we hold all of our private keys and it all goes over encrypted. And then of course it's encrypted at rest and encrypted in transmission. And then as far as, and this happens to be in AWS and we also have Azure as well. But the other thing too is we do burst our compute there. But one of the stipulations that we did internally to kind of mitigate and eventually if we did not project correctly, which we did not project, it grew a lot more quickly than we had anticipated, which is why we're going to bring it back in because it's not going to be economical long-term as this continues to scale, is our internal users and developers are mandated not to use anything that's proprietary to Amazon or that, you know, a common S3 provider would, you know, if there's some type of a proprietary implementation, that's something that either for our compute or storage instances cannot, it has to be stay broad, right? So that way we can move in and out. And hopefully we don't, that's only a one-time thing for us. So we don't use it as a DR, but we use it more as an archive, as a place just to keep the data there. But we are finding that the data isn't as cold as we had hoped. And that's increasing our costs, so that's why we're bringing everything back in. But that's managing our private keys and the encryption, and also managing how portable that data is one of the ways that we're able to go around kind of the financial aspects of this. But we're at this point incentivized to bring the data back in.
I mean, it sounds like the role for cloud storage, at least in the HPC world, is really as a cold archive. But that being said, are there any cloud providers on the planet that provide a solution that is more economical for keeping data forever than doing it on premise? Because if you're archiving things, you're presumably keeping it for a very long time. And what is the cost of paying on a monthly basis versus just throwing it in a bunch of tapes and sticking it in a box in the basement? You know, how do you reconcile those two things? That you want to keep the data forever, but the cloud is making you pay for it forever.
So if you want the data to be usable, I'd argue it's not entirely free just to throw it on tapes. Because you've got to keep recopying it to new versions of tape over time, and you've got the people management, and presumably part of what you're paying the cloud vendor for is they're the folks that have to do that.
Well,
But
I know a cloud vendor that can give you an exabyte for 12 million a year, and since it's an exabyte, you could probably get it for, you know, a significant discount. So if you add up all the staff and physical infrastructure and migration and risk and everything else. But to your point, Glenn, I mean, what you're saying, I think part of the issue for this community in the cloud is just you have the sunk cost of the data centers and the infrastructure you've already built, the experts, people, the culture and expertise of people like yourself and David Bonney, and this ability to kind of roll your own and make it work. Because you do have, you know, the classic case of I'm using my equipment 99.9% of the time. So I don't think that's going to change anytime soon. And the other thing is you have to, even if it did and you wanted to like get rid of data centers and go to cloud, you'd have to go teach Congress how to fund you, right? So how do you teach Congress how to do that? And when I go out and visit, you know, the classic Oracle enterprise customer, that's probably their biggest cultural thing. They're culturally, it's hard for them to consume cloud because that's not how they buy stuff. So, so with that said, so yeah, and by the way, I apologize to Ellen for proposing this idea for a panel since it's going over like a lead balloon. But everybody's like, I've never seen people quieter at this conference. But and I think part of that is because let's face it, you guys are essentially your own cloud providers, right? Los Alamos is a cloud provider for a certain group. NERSC is a cloud provider. And to be honest, you're good at what you do, all right? There's no public cloud that really does, it provides like a scalable compute infrastructure or anything that you could replicate, right? AWS is structured for different kind of workload. Microsoft is structured for its workload. We're structured for Oracle workloads. You know, I could, you know, put my flak hat on and tell you all these things about Oracle Cloud, which, you know, maybe you could use it that way, and it's potentially possible. But maybe the thing, I want to let this young lady talk, but basically, what about like use cases, right? Are there, because it's like any innovation, right? You're trying to adapt an innovation. You obviously can't jump wholesale in the public cloud, because quite frankly, we vendors haven't given you what you need yet. So are there specific use cases? Sounds like long-term storage might not be it. Are there use cases that might work? But go ahead, yeah, you had. Yeah.
So I guess I just wanted to go back to a comment you made about the cloud provider maybe not living as long as you need the data to be around. So my perspective comes, I worked at a university until recently, I work at NERSC now, but I think the situation is somewhat similar. So universities definitely have a tradition of preserving data, right, in the form of libraries, and certainly now digitally. And so there's things that are, cannot be reproduced, right? It might be scientific data, it might be something that has cultural heritage to it. Certainly more at NERSC would be some, scientific data. Glenn mentioned that there's things, more than 40 years old on the archive system now. And so I think part of the risk mitigation consideration has to be, if you put something in the cloud, does a cloud provider have the same sense of responsibility of making that data or that culturally significant video, what have you, available for future use? Or is it going to potentially become unavailable because it's not a financially, good decision for the company to continue and to provide that data for the long term, the way that a research center or university might see the value sort of differently and above and beyond the financial decision?
Right, and I think, in an ideal world, we could all write our contracts with cloud providers that would make sure there was a way to get the data on exit with the contract. But things can change. If a provider were to go out of business quickly, you could be in deep trouble. There are apparently some people that are looking at putting 2 copies of data in different cloud providers for just that kind of reason.
So it depends on your site requirements, right? So yeah, it might be cheaper to provide an exabyte of tape in your basement, but do you have a requirement around disaster recovery, continuity of being able to do something if the center burned down or if there was an earthquake? As an example, at NERSC, if there's a major earthquake, is there a requirement that your data is backed off-site? Does DOE have that requirement? For more classified sites, is there a requirement? There's obviously requirements around security. What are those requirements? Because there's a variation on black sites, how black a site might be. It might be that you're not allowed to have an internet connection at all. It might be that you're allowed to have internet connection under certain controlled circumstances. So you have all these different requirements to whether or not you can use a cloud service provider and it can be exploited properly. And then the other thing I'll throw out is Larry Ellison isn't interested in advancing the state-of-the-art computationally or storage-wise. Larry wants to make money.
That's a very key point. I mean, NERSC, we are not for profit. The cloud is a business model. It is for profit. So how do you reconcile those two? In a sense, NERSC is a competitor to the cloud. We provide a service for free to our users. Our users don't pay us a dime.
Except their taxes.
Yeah,
sure.
They pay their taxes.
Sorry.
But Larry's in it to make, as in every company who is publicly traded in this country is in it to make money. That's not the role. The role of DOE is not to enable, or NASA or NSF, is not to necessarily enable companies to make money. The role of these different government agencies is to do their specific functions. DOE, Department of Energy, to do research, NASA to explore space and do space science, National Science Foundation to support research and science in other areas, and the Department of Defense to provide intelligence gathering and defend the country. If as part of their function they give money to someone to provide them a service, all well and good. but they're not there to hand out money to companies.
Well, they handed out to Cray, John. I mean, Cray's a for-profit company. So
Cray
that's
is a
the-
for-profit, Cray is definitely a for-profit company, but they provide a service. So what I'm saying is, it's not necessarily, it depends on what the requirements are. Cray is not there to advance the state of the art.
Right,
Cray is
right.
basically serving the need of their customers, whether it's DOE or NSF or NASA or whoever.
Okay.
Right?
One more, yeah.
Yeah, so I've been tracking this whole government cloud thing for a while, and it's kind of this evolving thing, right? So initially, cloud came up and nobody even knew how to define it like 5, 6, 7 years ago. We had like the data center consolidation initiatives that started. We had there's been this whole consolidation initiative that's been going on since like 2002. There's various acts and whatnot that have been passed. We had the CIO's office that got stood up in government, right, under the Obama administration to start tracking, all these like data, broom closet data centers that have sprawled all over the federal government. And people are like, oh, cloud's the answer. We saw the intelligence community make a large investment in C2S with Amazon. Amazon stood up its own region, right, just for those guys. They went all in kind of private cloud or public cloud in a classified environment. They were kind of an early adopter, but what we're seeing is, why do people? What is the benefit of the cloud model? So one is it makes application deployment faster. 2, you can consolidate all your infrastructure in one location, so it's easier to manage. And then I guess 3 is like the security aspect of it, and 4 would be the consumption model. So you don't have to make those capital expenditures up front. So those are like the benefits of the cloud. I think that's one of the things people talk about, oh, the cloud, without talking about the benefits. So why would you want to do that, right? So initially everybody was like, hey, we need to look at all these, IS or, cloud service providers. So let's look at the CSPs, let's look at the AWSs, let's look at the Googles, and that's what we should do. What is shifting is we're seeing people are looking at the reasons to go to cloud, right? So the consumption model, the security, the co-location of your equipment, which we kind of do in the HPC industry anyway, because we deploy such massive systems. It would be crazy to have like your GPFS cluster distributed across 100 different sites, right? That would just make no sense. So we kind of are already doing the consolidation portion. What is becoming more and more popular is government organizations wanting to take advantage of the cloud benefits, but not necessarily doing it through a public cloud provider. So we're looking at, X as a service, right? So there's a company called Vion I work with. They did DISA's infrastructure or storage infrastructure as a service. So they co-located all the storage infrastructure, and then they provided a OpEx model, cost consumption model, to buy storage. So basically, kind of in the world of, I guess, the options you have as a consumer of technology, if you kind of look at under the cloud umbrella would be public cloud, right? Going with one of the AWS type organizations or Oracle or whatever. 2, you can do infrastructure as a service and pay Lockheed Martin or whoever to go consolidate your infrastructure and consume it at an OpEx model, co-locate your data so it's all configured and managed under one person or one group, so you have, security and compliance all under one hat versus like broom closet, SANs and NASs and parallel file systems that haven't been patched and updated in years and stuff like that. And then the third option is the agency private cloud model, right? So you go take the Azure stack, you park it on a bunch of Dell servers, and you build your own internal compliant cloud. So those are kind of the 3 different approaches people are taking. And then there's the mixes, right? There's the hybrid cloud, I guess, which would be like the 4th option, which allows you to burst out to Azure, but still have your own controlled hardware on premise. So anyway, that's kind of the 3 different things. So there's really different benefits, and I think it really depends on what your organization is trying to accomplish with a cloud model. So, I mean, what do you guys think about infrastructure as a service? So outsourcing your equipment to a company to run and save, will you save money? Have you guys done those analysis? Have you looked at deploying your own private clouds on premise or, you know, where are you guys at when it comes to that?
So a lot of the services you described, we actually do. So other scientific research organizations can burst to us. The Open Science Grid, if they need extra capacity, they can run on our system. If users have Docker containers, they can run on our craze. We put a lot of effort into making sure that we've found a secure way for users to run Docker containers directly on craze and get all the performance advantages of being on a cray without having to go to the public cloud or even a private cloud. And I mean, we also sell storage to industry. And we also provide cycles to industry for industrial projects. There are some strings attached because we are nonprofit, so the government has certain entitlements and requirements of, you know, open research. But, you know, in that sense, we are kind of a competitor to the cloud. We provide all those services to our users.
So I wouldn't say you're a competitor to the cloud. In essence, you have, I mean, this is what I hate about cloud and like big data and buzzwords like that. They're very nebulous. So, but in essence, you provide the benefits of the cloud model to your users, from a consolidation of equipment, the management, the outsourcing of the management, and a consumption model, it seems like, that is fairly elastic based on needs. So you actually have a private cloud you offer to other government entities or research entities, right?
I would say so, yeah.
Yeah, so that's kind of, you know,
It's like a managed cloud, it's almost, think of it as like your middle model managed cloud service, the one you just, like the DISA model.
Yep.
It's really kind of a DISA-like model.
yeah, yeah. All right. Cool.
Great, that was great insights, Ellen. Unfortunately, I'm gonna have to wrap it up because we need to have the last session, but do you have any other further thoughts that you or Glenn want to complete the panel with?
I think we've pretty much covered it.
Yeah, I'm out of ideas.
Okay, very good. Well, I got things boiling when I said that it was going over like a lead balloon, so everybody woke up and said, you know, we're gonna jump in there, so good job. All right, let's thank our panel.